Hi everybody, in this video we're going to go over the constructions that we've learned so far in this class. So the first one is that we're going to construct a perpendicular bisector of line segment AB. So our end result should be a line that that forms right angles with AB and that also cuts it equally in half into two congruent parts. We're going to put our compass on one endpoint and we're going to open up to the other endpoint or find the hole that best matches up to the other endpoint. And once we find it, we're just going to swing a circle. And then using the same compass measurement or the same hole if you're using the red compass, we're going to go on over to the other point B, the other endpoint, and we're just going to swing the same circle. The two circles should intersect on the bottom and also on the top. You can't see my top one because my computer screen cuts it off. Oops. Using your straight edge, connect through both intersection points. And that line that you've now created is the perpendicular bisector of line segment AB. It forms right angles where it intersects it, and it splits it into two congruent pieces. So if I label this point M for midpoint, AM is congruent to MB. Next, instead of making a perpendicular bisector, we're going to construct a perpendicular line through this point over here. The difference is this is not going to cut the line segment in half. It's going to just make a line perpendicular to the original one, passing through the given point. I'm going to take my compass and I'm going to put it on the point that I want the perpendicular line to pass through. And I'm just going to swing a circle. It doesn't matter what distance you use. The only thing that matters, let me make mine a bit smaller. The only thing that matters is that it intersects the line in two spots. I just didn't want to have to extend the line. You can if you need to. That's why I redid my line. So here are my two places where my circle intersects the line, and that's where my compass is going to go next. I'm going to take my compass, and I'm going to measure from one intersection point to the other. And I'm going to swing a circle using that measurement. And then I'm going to go over to the other place where the original circle intersected the line. And using the same distance I just measured, I'm going to swing another circle. This is super annoying on the computer because my computer is a bit laggy. And right through where those circles intersect, we're going to make our perpendicular line. Notice how it comes really, really close to going right through the point that we were given. And where it intersects the original line AB, it forms 90-degree angles with it. So the difference between this construction and the previous one is that the previous one also bisected the line segment. So it cut it in half, which means that it went through the midpoint. This perpendicular line construction does not necessarily cut the line segment in half, and it's used when you wanted to go through a specific point that you're given that may or may not necessarily be the midpoint. In this case, it's for sure not the midpoint. Okay, now we're going to construct a regular hexagon. So there's two ways of doing this. We're going to do it first the way that we did it in class. So what we're going to do is we're just going to take our compass and we're going to measure the length of the radius from the center to a point on the circle. And now with my compass, right here where the radius intersected the circle, using the distance I just measured, I'm going to swing a circle. Notice how there's two intersection points where the circle meets the original circle. It doesn't matter which one you go to next, but we do need to go on one of those intersection points. And we're going to use the same radius of the original circle. Then we're going to go over to the next intersection point. And we're going to keep doing it. And one more. And in total, you should have 7 circles, the original circle, and then 6 equally spaced ones that you created around the original circle. Now we're just going to connect all the places where the circles intersect the original circle. And there we have our regular hexagon. If you wanted to make the equilateral triangle, instead of connecting all 6 intersection points, what you could do instead is connect only 3 of the intersection points. And there you have an equilateral triangle inscribed in the circle. This is the equilateral triangle that will get you full credit on a test or the Regents exam because it's inscribed in the circle, meaning that all of the vertex points are on the circle. It could be facing a different way, but it needs to have the vertex points on the circle for credit. The second way to do the hexagon construction, and therefore the equilateral triangle construction because they're the same thing, is to do the same construction, just not to make full circles. And I'll show you what I mean by that. So I'm using the same distance that I measured. Oops. If I can not change the distance. Okay. See, instead of making a full circle, I'm making arcs or a part of a circle. It's the same construction. The circle helps better see why it makes a regular hexagon or an equilateral triangle. But with the arcs, it's much less messy. It doesn't look as nice at the end though. And then you can just connect. And on the computer, mine's not super accurate. If I did this super accurately, it should align with the original and be equally spaced. But we could connect and make our hexagon. And yours will be more accurate than mine because on the computer, it's not super accurate. And we could connect every other if we wanted the equilateral triangle. Okay, now we're going to construct the angle bisector of this angle over here. Oops. So what we're going to do is we're going to take our compass and we're going to put it on the vertex of the angle, so on point O. And we're going to swing any circle, it doesn't matter. The only thing that matters is that it has to touch the angle in 2 spots. So notice that it hits the angle here and it hits the angle here. So we're going to go over to each of those intersection points. And the distance that we're going to be using is we're going to measure from one intersection to the other as best as I can. Let me use a different color to swing this circle. Then I'm going to go over to the other place where the blue circle intersected the angle. And using the same measurement, I'm going to swing the same circle. We have a bottom and a top intersection point. And right through there, I'm going to draw in my angle bisector. So know this. Let's say I label this point over here, point E. Angle BOE is congruent to angle AOE. This half is the same as this half of the angle because we split it in half. Okay, now we're going to make a line that is parallel to a given line, and this is going to start the same as a perpendicular line. Let me just grab my compass. But instead of making a line perpendicular to this one, our end goal is going to be to end up with a line parallel to this one. So it's going to be a horizontal line rather than a vertical line. But it comes from the perpendicular line through a point construction. So I'm going to start off the same way that we did for that construction. I'm going to put my compass on the point that I want it to pass through. And I'm going to swing a circle. Remember, all it needs to do is hit the line in 2 spots. Okay. Gonna grab my compass, gonna put it on one of those intersections. And I'm gonna match up to the other intersection. And I'm gonna swing a circle. And then on the other intersection point, I'm gonna swing the same circle. And through the intersection points, I'm gonna make my perpendicular line to the original. So now we have a perpendicular line. Our next step is to make a parallel line. So the best way that you can approach this is by turning your paper, and just to go over why how we're going to get the parallel line. Remember that 2 lines perpendicular to the same line are parallel. So AB is now perpendicular to this line. If I can make another line here that's also perpendicular to this line, they will be parallel to each other because 2 lines that are perpendicular to the same line are parallel. And that's the justification for this construction. The best way to do this is by churning your paper. So I'm going to churn my paper. Let's see if I can do that. No, that didn't work out the way I wanted it to. Well, it's not letting me turn my paper here, but I suggest that you turn your paper horizontally. So it's sideways. So I'm going to use a different color so this doesn't get confusing here. And what I'm going to do is I'm going to put my compass point back on point L. And I'm going to repeat. But now I'm going to be using this line. So what I'm going to do is I'm going to make a circle that intersects the line in 2 spots. So here and here. Gonna open up from one intersection to the other. And I'm gonna swing a circle. And then on the other intersection point, I'm gonna swing the same circle. And it gets messy, which is why I recommend different colors. Right through where my 2 new circles meet, I'm going to draw in my perpendicular line. And notice how my perpendicular line is parallel to the original line. So if I call this line L is parallel to AB. So once again, the justification is that both of these lines are perpendicular to this line, to the same line, so they have to be parallel to each other. Our last construction is that we are going to construct a square. So we can do a square inscribed in a circle, or if we're just given a line segment, then we can construct a square not in a circle. I'm going to do this one first. So the best thing to do is to extend your line segment using your straight edge as best as you can. And this is not going to be super straight because I'm on the computer doing as best as I can do. We need to get right angles for a square. So I'm going to make a perpendicular line through point A. So compass on A. Distance doesn't matter, it just has to intersect the line. Oops, I keep clicking on that. It has to intersect the line. Computer's so annoying. At 2 spots, here and here. Open up the width of the intersection, swing a circle. On the other intersection point, swing the same circle. And right through there is going to be my perpendicular line through the intersection points. As you can see, the computer is so annoying. I keep clicking on one thing and it clicks on another. This computer is not the best. Okay. I need to know how long to actually make that side. It's got to be the same length as AB because squares have 4 equal sides. Okay. You'll see that this computer is so annoying anytime I try to make a video. I'm going to put on B. And I'm going to open up and I'm going to measure to A. And I'm just going to transfer that measurement down here. And that should be point D because A, B, C, D. Point D. So over here, I now have AD congruent to AB because I made it the same length. And since I did a perpendicular line through point A, I have a right angle here. I also need a right angle over here on this side. So I'm going to do another perpendicular line through point B. So same construction. Put your compass on point B, make a circle. It just has to intersect in 2 spots. Open up the length of the width of the intersection. Swing a circle over to the other intersection point. And as you can see, I'm not 100% accurate with the computer, but we try to be as accurate as we can be. And right through those 2 intersection points, I'm going to draw my perpendicular line. So this ensures that we have a right angle over here as well. And I just need to make sure the side is the same length as AB, so all the sides could be the same. So I'm going to take my compass and I'm going to measure. Once again. Then I'm going to swing that measurement down here. And that's going to be point C. Now the last thing I have to do is just connect my points together. And here A, B, C, D is our square. Now we know that all the sides are equal because we measured them all, and we made them the same length as AB, our starting line segment. We have our square. And since we made perpendicular lines through the point, there's also right angles down here. So we have a square. To make it inscribed in the circle, what we need to do is we need to start off with a diameter. So that goes from one end of the circle to the other through the center. It doesn't matter which way you make your diameter facing, it just has to be a diameter. And what we're going to do is we're going to make the perpendicular bisector of the diameter. So we're going to go over to one of the endpoints, and we're going to open up. Sorry, on the computer, it's so annoying. So one of the endpoints, and I'm going to open up as best as I can to the other endpoint. And I'm going to swing a circle. And then without changing the radius on my compass or the hole, I'm going to go over to the other endpoint and make the same. Notice how there's an intersection below and above. Right through those two intersection points, I'm going to make my perpendicular bisector. Since we bisected the original segment, it's splitting it in half. It's also forming right angles with it. You might be wondering, how do we get our square? Take your straight edge and connect the intersection points together. And there we have a square inscribed in the circle. And the reason why this construction works is because the diagonals of a square are congruent and perpendicular to each other. So by doing the perpendicular bisector of one diagonal, we were able to find the other diagonal of the square to ensure that if the diagonals are congruent and perpendicular, then we know it's a square.